Hi, my name is Struan and I'm a scientist at Eyes on Science, and today I'll be showing you how to work with our smallest nanopores. The NP80 and NP100 are used to measure particles down to 40 nanometers. Operating the instrument at these lower limits is significantly more challenging and typically done by expert users. According to nanofluidics, the decrease in nanopore size results in significantly more force being required to flow liquid through the nanopore channel. This makes it much harder to both wet the nanopore and also to dislodge blockages once they occur. The first challenge to working with small nanopores is wetting them completely. During the wetting step, it is normal to be using more force than usual when tapping or plunging with the pad. You will also find yourself tapping and plunging the nanopore much more often than you would with a larger pore to wet it. This is required in order to dislodge any air trapped inside the nanopore, and to force the electrolyte through the nanopore to bridge the upper and lower fluid cells. When working with small nanopores, start with firm, gentle taps to begin. Then increase the strength of your hits. An alternative to a pad for this is a small hard plastic object such as a 15mm Falcon tube. Take care when hitting forcefully, as small pieces of plastic can break off the pad. Appropriate eye protection should be worn at all times. If you are having difficulty wetting a small nanopore, one thing you can do is stretch the nanopore up to 49mm during manual wetting. Operating at a higher stretch will make the nanopore easier to wet, as it allows a greater volume of liquid to flow through the nanopore and reduces the force required to dislodge air bubbles inside the nanopore. Because you are tapping with the back of the pad harder and more often than usual, you are much more likely to form bubbles in the lower fluid cell, and you may have to reset up the nanopore several times during the wetting step. Plunging with the pad during this step will apply more force than the pressure nozzle, and you may be required to perform several cycles of 5 plunges to get the pore wet. One thing to be cautious of when wetting small nanopores is that they can appear fully stable before they are fully wet, leading to them sometimes having a large increase in baseline current in the middle of the measurement as the last part of the nanopore wets. The best method to reduce this occurring is, once you have a stable baseline current, give the pressure nozzle a few gentle taps with the back of the pad. If the current continues to increase by more than 0.5 nanoamps when hit, then the pore is not fully wet yet. Keep tapping gently, then check if your current changes by less than 0.5 nanoamps over the course of 60 seconds. If the current continues to drift, repeat the tapping until it is stable. This process is easier to check with a baseline of about 120 nanoamps, so adjust the voltage accordingly to achieve this baseline. As always, when working with biological samples, coat the nanopore with Eyes-On coating solution to protect the nanopore from non-specific binding. Calibrating a small nanopore is typically done with CPC 100s. If you are intending to measure particles in the 40 nanometer size range, your blockade size for the CPC 100 particles should be at least 0.5 nanoamps in size. Because of how small these nanopores are, blockages occur much more frequently than in larger nanopores. This can be because your calibration solution or sample is too concentrated. Typically, a 1000 times dilution of CPC 100s is used when working with small nanopores, giving a concentration of the order of 10 to the power of 10. If you can, dilute or concentrate your sample to get a particle rate in the range of 500 to 1500 particles per minute for all 3 pressures measured, as this gives the best balance between having a high enough particle rate to measure the sample quickly, while not being high enough to cause major blockages. Proper preparation of your sample will decrease the likelihood of your sample blocking the nanopore. For a human plasma sample, centrifuge the plasma at 10,000 G for 10 minutes to separate out any large solids. If there is a fat skin on top of the sample, use a clean pipette tip and touch it to the fat layer. The fat will stick to the plastic pipette tip and be removed. Then load your sample onto an appropriately sized Eyes-On QEV size exclusion column and follow the instructions in the corresponding user manual to isolate and collect your sample, either manually or on the automatic fraction collector. Before running your samples on the Xoid, they will need to be diluted. The dilution factor depends on your sample and if you are measuring the individual fractions or the total pooled volume. but a good starting point for human plasma samples is a 10-fold dilution. Adjust the dilution of your sample to give a particle rate of between 500 and 1500 particles per minute. If your sample keeps blocking the nanopore, you can put your sample through a 0.22 micrometer millipore spin filter to remove any large aggregates that are blocking the nanopore. This may decrease the accuracy of the concentration measurement though, as some particles of interest may get trapped in the filter. Once you have completed your calibration measurement, load your diluted purified sample into the upper fluid cell and start your measurement as usual. One of the keys to a successful measurement of biological samples is hitting pause as soon as something goes wrong in order to preserve the quality of your data. For example, during measurement, this plasma sample has a minor blockage. The pause button is quickly pressed and the blockage was fixed by 2 sharp hits with the back of the pad. Upon resuming the measurement, a further 2 blockages occurred. Again, the pause button is quickly pressed to preserve the quality of the dataset, then gentle taps are applied. While a gentle tap was enough to fix the second blockage, the third required a strong hit in order to stabilize the baseline. You can see the first hit appeared to stabilize the system, but it quickly destabilized again. This is normal when working with small nanopores, and samples do take longer to measure, especially if the nanopore needs to be reset up and the measurement started again due to bubbles in the lower fluid cell or a major blockage. For example, this plasma measurement took an hour and a half from wetting and coating through to calibration and measurement. If you have any questions or would like to know more, please contact us at support@izon.com.